If the world went dark tonight, most of us would blame a war, a hacker attack, or maybe a simple failure at the power company. But there's another culprit, one that's older than any nation and stronger than any grid: the sun. This isn't just a theory, it already happened once, so violently that the most advanced technology of its day began to spark, burn, and behave as if it were haunted. This is the true story of the night. The sky caught fire, and humanity realized we were living on borrowed power. Picture the middle of the 19th century. A new miracle was stretching across continents. The telegraph. For the first time, messages no longer had to travel by horse or ship. They could move through metal wires, faster than any human body could ever carry them. It was the closest thing to a global nervous system the world had ever built. And that is exactly why what happened next was so terrifying. Because when the sun struck, it didn't just hit a single city, it hit the entire network. It all started on the 1st of September, 1859. An English astronomer named Richard Carrington was doing his routine work, observing sunspots, recording the changes, and sketching what he saw through his telescope. There was no drama, no superstition, just quiet science. And then, it happened. A blinding white burst erupted on the sun's surface, so bright it looked like a lamp had suddenly ignited inside the star itself. Carrington froze. For a moment he suspected his own eyes were deceiving him, but he wasn't the only one. Miles away, another observer, Richard Hodgson, reported seeing the exact same brilliant flash. Two people, two independent observations. A phenomenon was recorded, described, and later published in scientific journals. A solar eruption of enormous scale had just announced itself, and Earth was about to pay the bill. Just hours later, the planet's magnetic shield began to shake under the assault. The night sky lit up with spectacular auroras, but in places that almost never saw them. People in the Caribbean, in Mexico, in Cuba, looked up at skies glowing with eerie shades of red, green, and colors that just felt wrong. Some people thought dawn had arrived hours early. Others believed a distant city must be on fire. And plenty of people simply stood in stunned silence because they had no words for what they were witnessing. But while everyone was looking up at the sky, the real danger was happening down on the ground, at desk height. The telegraph, the pride of the modern world, began to fail, and not gently, it failed violently. Telegraph operators across North America and Europe reported getting electric shocks from their own equipment. Some of the machines threw off sparks that set nearby papers on fire. Telegraph offices were filled with the smell of scorched metal and burning paper as the equipment behaved as if it had been plugged into something far more powerful than its own batteries. And then came the detail that still makes this event feel so unreal today. In some reports, operators completely disconnected their batteries, cutting off the power source, and the telegraphs continued to transmit for a short time anyway. The keys kept clicking, sending garbled messages through the wires, powered by nothing. It was as if the Earth itself had become the power source, as if the planet had turned into a giant, trembling, and unpredictable battery. That is what a severe geomagnetic storm can do. It can induce powerful electrical currents in long conductors, like the thousands of miles of telegraph wires that crisscrossed the globe in 1859. The sun didn't turn off the system, it flooded it with an overwhelming surge of energy. Our planet's magnetic field protects us from solar radiation most of the time. It's an invisible shield. But when the sun ejects a massive cloud of charged particles, a coronal mass ejection, that shield can be compressed and disturbed so strongly that it creates powerful electrical currents in the ground beneath our feet and in any long metal lines on the surface. Telegraph wires were perfect targets, long, exposed, stretching across huge distances. And this is the part people often miss when they hear this story. The Carrington event happened in a world with no satellites, no national power grids as we know them, no internet, no smartphones, and none of our modern total dependence on electricity. Yet it still caused widespread chaos, confusion, and damage. So now imagine the same physics, the same solar storm, happening today. Not hitting simple telegraph wires, but striking our high-voltage transmission lines, our delicate transformers, our GPS satellite constellations, our aviation and communication networks, and the complex digital infrastructure that keeps water flowing, hospitals running, and our entire economy functioning. The Carrington event is history, yes, but it is also a blueprint for a terrifyingly modern vulnerability. This is not just a Victorian curiosity, it's a warning, and the world has seen smaller reminders since then. In March of 1989, a major geomagnetic storm, far weaker than the Carrington event, contributed to a large-scale power disruption in Quebec, Canada. The entire province went dark for over 9 hours, proving that modern grids are absolutely vulnerable, not just antique telegraph lines. The scale was different, but the lesson was exactly the same. Long, interconnected electrical systems can be pushed into catastrophic failure by a storm that begins 93 million miles away. The scariest part of the Carrington event isn't the sparks or the strange auroras. It isn't even the idea of a temporary blackout. The truly frightening part is this. The sun didn't do anything unusual, not for a star. It wasn't a conscious act. It didn't aim at us. It didn't warn us. It didn't have any malicious intent. It simply behaved like the sun, and our civilization, built on a delicate web of invisible currents and digital signals, briefly discovered just how thin its safety margin really was. Because our modern world doesn't collapse with explosions and fireballs, it collapses with silence. No signal, no service, no refrigeration to keep food and medicine safe. No transport coordination to move supplies. No electronic payments, no reliable navigation. A city can look perfectly intact from the outside, with every building standing, and still be effectively offline, thrown back into a pre-industrial age. And if you think this is a problem safely locked away in the 19th century, consider this. In July of 2012, a powerful solar eruption, believed to be on the same scale as the Carrington Event, blasted through the region of space that Earth occupies. But the planet was not in that exact position at that exact time. We were on the other side of the sun. In plain terms, we missed it purely by timing. A near miss doesn't prove that a catastrophe is guaranteed to happen tomorrow, but it completely destroys the illusion that these extreme events are impossible in our modern era. The sun is still capable, and the calendar is not a shield. Richard Carrington's legacy isn't a monster story, it's evidence. It's a documented case study. A human being witnessed a flash on the sun, recorded it with scientific precision, and just hours later, Earth's most advanced technology responded in a way nobody expected. It connected the sky to the ground, the star to the wire, and that connection is the real, enduring message of this event. We are not separate from space. We live inside it, subject to its moods and its power. The Carrington Event was not the end of the world, but it was a chilling glimpse of how our world could be ended without a single shot being fired. And here's the final twist that most people never hear. If a Carrington-level storm were to hit us today, you probably wouldn't notice it in the sky first. You would notice it in the palm of your hand. A screen that won't light up, a signal that won't return, a device that connects you to everything, suddenly connecting you to nothing. You'd notice it as your city, your country, your world, suddenly feels older, much older. And all the while, the sun, bright and indifferent, would just keep shining. If you want to hear what happens next, I'll tell you the story of the moment scientists realized just how close that 2012 near-miss really was, and what the world's space weather teams do when they believe the next big one is on its way. Subscribe, and stick around, because the most dangerous threats in history don't always come from other people. Sometimes, they come from the only star we've ever learned to trust. Thanks for watching.